Today you'll be finding the expected value from a probability distribution. A probability for a random variable consists of the two things. It consists of the collection of all possible values of a random variable and the probabilities that the values occur. Okay, so of particular interest, the value we expect a random variable to take on is denoted as mu sub x for the population mean, or E of x for expected value. So the expected value of a discrete random variable can be found by summing the products of each of the value by the probability that it occurs. This is the formula that appears on your yellow formula sheet. So you're going to essentially take the sum of all of the x values times their probabilities. Now, you need to make sure every possible outcome is included in that sum and verify you have a valid probability model to start with. This is a link to another random variable video. So if we look at our first example, we have an insurance company offers death and disability policy that pays 10 grand when you die or 5 grand if you're permanently disabled. It charges a premium of only $50 a year for this benefit. Is this company likely to make a profit on selling such a plan? Well, to find the profit, notice we have a probability distribution. Real quick mental check. If we add our probabilities together, do we get one whole? And the answer to that would be yes. So our expected value or expected earnings, we'll take our 10,000 times 0.001 plus the next disability, 5,000 times 0.002 plus 0 times 0.997. And then we type that into a calculator exactly like we see, and we do get an expected value of $20. So we can expect they would make a profit of $20 per policy. Here is another example. So notice we're on Valentine's Day. The Quiet Nook restaurant offers a lucky lover special that could save couples money on their dinners. When the waiter brings the check, he'll also bring the 4 aces from a deck of cards. He'll shuffle them and lay them out face down on the table. The couple will then turn one card over. If it is a black ace, they'll owe the full amount. But if it's the ace of hearts, the waiter will give them a $20 discount. If they first turn over the ace of diamonds, then they'll get to turn over one of the remaining cards, earning a $10 discount for finding the ace of hearts. What is the expected discount for a couple? Okay, well, the unknown that we are looking, the random variable, is the discount. So we're going to start off with saying let x equal the discount. Well, what is something else that we obviously know? Well, we know that we get a $20 discount if we obtain the ace of hearts. So I know we get the $20 discount if we get that ace of hearts, which if I only have 4 cards, that's a probability of 1 over 4. We also know we get a $10 discount if we obtain the diamond first and then find the ace of hearts. So the first fraction there is the probability of us obtaining the diamond and the probability of us obtaining the ace of hearts, because it's like we already found the diamond. There's only 3 cards left. One of them is the ace of hearts, which is 1 over 12. And then the third thing we know is there's no discount, meaning we don't get 20 or 10. So you would do 1 minus 1/4 plus 1/12. Okay? Then if it were me, I would structure it into a table as a visual. So I know that my 3 events is if I get the ace of hearts, the ace of diamonds, then the ace of hearts, or I get a black ace. Okay? We also know that we found from earlier the ace of hearts is a $20 discount, and we found it to be a probability of 1 over 4. For the next one, we know the discount is $10 and the probability is 1 over 12. And for the third one, the discount is 0 and the probability of that is 2/3. All that's left for us to do is to find the expected value and then type it into a calculator. It does end up giving us $5.83. Time to practice. The end.